So here I want to approach -3 from the left. So this little negative up here means I'm approaching from the left-hand side. So as I approach -3 from the left-hand side, I want to look at what the y coordinates are doing. The y values are coming in towards 4. Here it says f prime of -4.5. So this means the slope of f at x equal -4.5. So if I go over here to -4.5 and I look here, I can see this slope, and it looks like it's down 2 over 1/2. So the rise is -2 over 0.5. And if I compute that, I get -4 as the slope. So the rise, I went down from 10 to 8 and over 1/2. Here I'm looking at the limit as x approaches -2. Since it doesn't say right or left, it's a two-sided limit. So I want to look as x goes to -2 from both sides. What is the y value doing? So from the left, it looks like it's approaching 8. From the right, also approaching 8. So since the left and right hand limits are approaching the same value, the limit is 8. And then this, I notice, is the definition of derivative. So this, again, is looking at the slope of f. The slope of the tangent line at x equal -5. And if I look at it, it's linear there as well. So it's going to be that same slope that we had before, so -4. This one says I'm looking at the limit of f as x approaches 0.5 from the right. So this is from the right-hand side. So as I approach 0.5 from the right-hand side, my y values are going up to 9. So 9 is the answer there. And then this says the derivative of f at x equal 3. And so if I look at x equal 3, I see that I have a cusp there. In other words, the slope from the left and right are not the same. So since that's the case, my derivative does not exist. So I'll write DNE for does not exist. Now here, this is another way to write the definition of derivative. The limit as x approaches 2 of this thing. So if I look when x equals 2, what's my derivative? And I can see that the slope of the tangent line there is 0. So this is looking at the slope of f at x equal 2, and that's going to be 0 because it has a minimum there. Now I want to look at the limit as x approaches 5 of f of x. And so as I come in towards 5 from the left and right, so it's a two-sided limit. As I come in from the left, it looks like the y value is approaching 2. And as I come in from the right, the y value is approaching 9. So since the left and right limits are not the same, this limit, two-sided limit, does not exist. And then the last one says the limit as x approaches -3 from the right. So let's go over here to -3, and I'm going from the right-hand side. And if I approach -3 from the right, the y value is getting bigger and bigger without bound. So in this case, we say that the limit is infinite. So it's kind of a special case of the limit not existing, but it doesn't exist in a particular way. And that way is that the limit is increasing without bound. And so the limit as x approaches -3 from the right, we'll write that down as infinity. Then on part B, it says identify an x value in the interval -10, 10, where f is continuous but not differentiable. So we've already kind of identified that place. We said that the limit as x approaches 3 does not exist, right? But it's continuous there because the function doesn't have any breaks or gaps or anything at 3, but it does have a cusp. So that is x equal 3 is that place. So for this one, I want to compute left and right hand limits as x approaches 1. And so when I'm looking at this description here, first I want to do the limit as x approaches 1 from the left. And so I'm going to start with this equation because this is for the values x less than or equal to 1. And so, I'm going to write the limit as x approaches 1 from the left of, I'm going to use this function when I'm computing it from the left. 2x squared minus 7x minus 6. Of course, that's continuous for all values of x, so I can go ahead and plug in that 1. So 2 times 1 squared minus 7 times 1 minus 6. So that's 2 minus 7 minus 6, which is negative 11. And if I come in from the right-hand side, I'm going to use this function because this is true for x values greater than 1. So I'll look at the limit as x approaches 1 from the right of this function, negative 5 minus 8x. And if I just compute that, I'll have negative 5 minus 8 times 1, because, again, that's linear, so it's going to be continuous for all x, so I can just plug in. Negative 5 minus 8 is negative 13. Then the question, does the two-sided limit exist? And so the answer is no, because the left and right hand limits are not the same. So for the limit to exist, the left and right hand limits need to be the same. And then it says, is f continuous at x equal 1? And the answer to that is no, because to be continuous, you need the limit to exist and the function value to equal that limit. So because the two-sided limit does not exist. So we need two things to happen. We need the two-sided limit to exist, and we need the function value to equal that same value as the two-sided limit. But we do not have one of those conditions, so it is not continuous there.